Welcome to Quantum Kinetic's First Diffusion, Season 2, Episode 5. I'm here with
Jason MacCoy.
Jason MacCoy. It's always so good to have you on. What are we going to be talking about today?
Well, last time we left off, we were talking about the workings of the inner ear and how there's these three bones in the inner ear that help to amplify the sounds that hit the eardrum.
Mm-hmm.
And you were mentioning something about how the ear has these different like parts to it.
Mm-hmm.
So how does that work? What is the outer ear, the ear canal, and then like the eardrum, and then inside the head and ear?
Right. So there's three pieces to the entire ear.
Okay.
There's the outer ear, which is that thing that absorbs all, it's like a radar. It absorbs all the waves.
Uh-huh.
Then there's the inner ear, which has that hammer tiny bone amplifier, which can amplify the sound by 22% or 22 times. It's huge factor increase.
Wow.
And then that goes into your nerve, and that signal goes into the cochlea, which is the inner ear. And that then in the cochlea is basically a Fibonacci spiral liquid chamber, resonant chamber. It's like a piano that's swirled around into a circle.
Wow.
Yeah, and then in the circle, in the liquid, there's these little hair particles, or not particles, but like hair follicles. Thank you. Yeah.
I know, particles, follicles.
Okay, I need another drink. No.
Yeah.
And so then those signals, those wave oscillations, particle oscillation as an energy generator, those waves get turned into a signal, electrical chemical signal that goes into your brain.
Huh.
And then your brain discerns if it's a cat in the bushes or a bear in the bushes or whatever, or a beautiful woman walking up to you. And so your brain has the ability to take a very small hertz frequency of the universe and turn it into an electrical signal that your brain can interpret. Very similar to our circuits, where we take basically a small, tiny input and then increase it by a huge factor using the arc reactor technology of fusion on demand. And so we use Mother Nature's processes to create these huge effects, just like Mother Nature.
Well, it's so many of the designs of Mother Nature are just perfectly done. It's like, have you ever seen in like a magnification of like a shark's skin? Have you seen the little, this scale? They're like little scales, and they all have like water grooves in them for channeling water and keeping bugs off, or parasites off them and stuff. It's a perfect design. It's amazing.
Mother Nature has all the secrets already figured out, and our job as human beings on planet Earth is to not be so conceited and like arrogant that we know everything, because we definitely don't.
No.
And so is to be like good scientists, is like observe the data points, observe the universe, and say, hey, if Mother Nature is doing it a certain way, can't we do it that way too to make it better?
There is a thing I saw on whale, like the arms of a whale. They're on the front of an arm, the arms of a whale. Are they called arms? Are they fins?
I think they're fins.
But they used to be arms, right? Or they're fins.
Well, if you look at the bone structure of a whale's fin, it looks like a hand.
Right. Okay. So
like phalanges, right? The fingertips.
Right. So on the front edge, there's these bumps. And for a long time, they're like, why do they have these bumps on the front of the fin?
Are you talking like a humpback whale? They have those like weird bumps?
Actually, in a lot of ways, they kind of look like a big boat. Like they even have lines going down their stomachs, and you know what I mean? They like kind of look like the underside of a boat. They must perform the same function.
Well, the tail, even the tail of a whale is very, like when you see it breach up and it has its tail up, it has that really interesting geometrically shaped balance effect to it. It kind of strikes you like, whoa, that's a very interesting shape.
Right.
It's a very important shape. I don't know why it's important.
Well, where I was going with that, with the fin thing, is those bumps on the front of the fin actually help channel water in a certain way. And they've started using that design on propellers. And those propellers are more efficient.
Are these like submarine propellers or just normal like commercial propellers?
They're both. I think it does this. You would know more about the physics of what's going on here. They somehow minimize the amount of cavity.
Oh, a cavitation.
Cavitation.
Cavitation's bad on a submarine,
Right.
prop because it makes loud noises.
And it wears out the propeller. For
Oh yeah,
some,
it pits
reason.
it. It makes these little pits in it.
Why is that? Because it's a vacuum. It's constant popping a vacuum, and is that why?
Yeah, and so when you have a cavitation event, it causes a lot of stress factor in a localized region. It's kind of like a cavity resonator. Like if I take, for example, this bottle, the neck, just like your ear, the canal of your ear, there is a neck to it. And if this liquid is all the way up here and I blow over it, you see how this is a really high-pitched resonator.
Let me do this one. This one's, fortunately drink this one on our previous taker, but here we go. Hear how low that one is?
Yeah. Because your neck is actually quite long now. Like you see how long it is? Your resonator. And this is called a Helmholtz resonator. And this is a physical mechanical design that actually can be used in circuits.
Oh yeah, you would keep mentioning circuits, and I'm like, how does that relate to the ear? Or
okay. So, and the way the ear amplifies the sounds of like hertz in the air, compressional waves, is that bone inside that little tiny bone, that three
bone
structure
system. Yeah.
The eardrum, which is the foam basically, picks up the pressure. The bone inside starts ringing, and that ringing pushing pressure goes to the cochlea, which essentially is the keyboard. It's a spiral keyboard that picks up like different and then your brain goes, oh, that's an electrical chemical. That's exactly what it does. And because the cochlea is filled with water or a liquid, it actually has the ability that speed of sound goes super quick. It's a really responsive reaction, just like a circuit in the Quantum Kinetic Well technology that we use with the arc reactor technology. So what we've done here at Quantum Kinetics is we've taken the understanding of Mother Nature and put it into a circuit that does nuclear fusion on demand safely and reliably. And it's patented, trademarked, and copyright protected and research verified. It's like the future, man, is here.
Yeah.
And we have the ability to manipulate unique forces.
That is awesome. I've talked about this before, but I think it'd be fun to do a piece on the future technology and what
I'm sure everyone would like.
Yeah. I mean, the graphics would be awesome. I'm a big fan of that. Yeah. And, it would be so cool to look at like what technologies and what aspects of society it could help.
Yeah.
Because that's kind of the thing, right? The technology is exciting, but the idea that our lives could be transformed with technology that could create a paradigm shift in, what we can do.
That thought you just had reminded me of, do you remember the old Star Trek with James T. Kirk where he gets beamed to a planet with that evil monster that he has to do battle with, and he has to like go and make like a rudimentary lathe? Yes. He's throwing rocks at him, and Spock and the crew is watching him on the teleprompter and stuff like that. He's like, oh, he's beginning to learn. Like he's going and finding the minerals. He's going and finding the bamboo gun barrel, right? And he's starting to put the rocks in, and he's going around and he's figuring it out. That episode reminds me a lot of what we're talking about here. Is like we're beginning to realize that Mother Nature, she's already showing us all the secrets. We just have to pay attention. And if we pay attention well enough and we design our devices well enough. I mean, even the wing of the bird and, Boeing and all this stuff, like it's all inspired by nature.
Well, have you ever seen the sort of side-by-side thing where they show, I think it's a Peregrine Falcon and like a stealth bomber.
B-2 bomber.
And they kind of the profile looks the same.
Yeah, when you look at it straight on, it exactly has the same shape. Even the cockpit of the nose. The really? Bird in the cockpit, it's very similar.
I saw the other day, maybe it's a new, I don't know how new it is because, I always feel like these technology companies are like 30 years ahead. And
I would say
we
some
were
of them are. Yeah.
we're just looking at we're looking at the old stuff, but it was a cross section of a wing with a flexible like skin,
Mhm.
and you could see inside of the wing, and it had like this sort of crisscross like pulley system, and you could flex the wing
Mhm.
so that the shape of the wing could morph.
Yeah,
How
it's
crazy is
a
that?
dynamic, shape-shifting
Yeah.
exoskeleton.
Yeah, exactly.
Yeah, and I don't know how far I want to go into that, but like the pistol shrimp, I don't know if you're familiar with the pistol shrimp, but the way that the shrimp's pincer is designed, and then when it fires it down, it creates a tiny bubble of cavitation that's so powerful and so perfectly geometrically shaped, like a resonator. It amplifies and then detonates instantly the water of the ocean. And actually submarines, like military submarines, can actually detect when a pistol shrimp is firing. It goes click, click,
Really?
click, click. And they can actually hear it on the sonar and the sensors. Yeah, it's crazy.
And doesn't it even make a little spark?
Yeah, it's called sonoluminescence.
Wow.
It makes
like sonic?
It's a sonic boom basically in the water, and it creates a blue flash, which is basically hotter than the sun.
Just because it's doing it so fast, it's creating a cavity in the water, or like a empty cavity?
It's totally like this, right? Like, for example, if this is just normal ocean water and everything's equalized, when the pistol shrimp clicks it down, his shrimp arm, it basically makes the localized universe in that water basically lose and cavitate in, because the forces aren't pushing back anymore because they're all being pushed in. And then it pops. And there's this energy field that comes out, and then it tries to renormalize. It's almost like the veil, like we were talking about in the last episode with you on. The veil momentarily is pulled back and then open and closed. And then all this energy weeps out. And then it stuns its prey.
Yeah.
And then it just eats it.
And it can shatter like shells of...
Oh, yeah, mollusks and stuff like that. It just...
It's amazing. There was another... we were looking at this the other day when we were doing a Zoom thing. That prehistoric fish that has the jaw structure, that has what you said, it had to have three.
It was a
hinge.
hinge.
Yeah,
it's like when we're going into like Home Depot and you have to get the.
I've used that thing before.
It's like, honey, we need to have you trim the trees. Go get a clipper. Like, oh, okay. And you look at the way it's designed.
Yeah,
it's two hinges, but there's a third hinge in the middle, at a certain angle,
right.
And as you open it, and then you close it, it gives you an extra magnification of compression power.
Right.
And that's Mother Nature's process too.
It's so interesting how that those mechanical designs or even chemical designs, like there's a bug that can create a chemical reaction that burns the predators that are trying to attack it. It's some kind of beetle that shoots out this, like, it mixes the chemicals right when it is trying to defend itself, and it like burns it creates a chemical reaction.
They used to make missiles that did that actually back in the day. They would have a catalyst that when they'd fire the missile off initially at the explosion, at the same time they would mix certain chemicals together, and it's proprietary what those chemicals were. But as it was doing that, it would make basically super electrolysis occur and like current flow, and then they'd use that energy to keep the missile going.
Wow.
So it was a electrochemical, reaction like the beetle to burn and make energy or defend itself.
Yeah, there's so many designs in nature that are just I mean, as an inventor, as a creator, I see you have all these mechanical things around here, even 3D printing, right?
Yes.
I heard somebody one time say that your body, the best 3D printer in the universe is your own body, is a biological body. Because think about it. Your body has made bone. Mm-hmm. It's made flesh, tendons, blood that has iron in it, that's absorbing oxygen. And you have
your lungs.
Your eyes have a lens in them
that absorb electromagnetic radiation and turn it into electrochemical signals so you can see things.
Right, yeah.
Just like your ear?
Yeah.
This is really important, Jason. Your ear is picking up a hertz frequency. Your eyes pick up a hertz frequency. Your body is able to detect electromagnetic energies at different frequencies, like on the keyboard, to interpret the universe to stay alive.
Yeah. You have a lot of sensors on your body: heat, vision, sight, sound, smell, taste, touch, intuition, maybe.
And that one's coming. That is going to be the last evolutionary state for the human race, is the intuition. Like when you get that gut feeling, like, oh man, I shouldn't do that, or I should do that. We're going to get so good at experiencing the higher collective consciousness. Dana Kipple would call it plasma intelligence. We're going to get so good at that we'll be able to know if people are lying. You know, like lying won't even be a thing anymore. And that'll could you imagine?
That'll put a lot of relationships to the test, I could imagine. I mean,
but it'll also let everyone know who you really are. I mean, like it will be basically where we need to be as a society.
Well, you and I were talking about that on a phone call.
Oh, yeah.
This was an interesting one, right?
We always have interesting.
I know. We should almost record the phone calls. I was like, but the conversation was something along the lines of your body has a nerve system that is electromagnetic, right? I mean, of course, your brain is the biggest organ of that, right? Besides, in your body has quite an extensive like network.
Yes.
In a weird way, you're kind of like an antenna.
Yes.
And a receiver.
Yes.
Like you're probably, when they check brainwaves of people that are sleeping or meditating,
right,
they are very specific. And so maybe we can.
They're very low frequency.
Yeah. And so is it possible that maybe we can, like, you could pick up on somebody's thoughts because your body is literally an electromagnetic
antenna? Receiver?
Yeah.
Yeah, it's the basic...
And broadcaster too, right?
Correct. You literally, human body, and this is what people need to understand, and good point, is that the human body is nothing more than a very high level, high technology radio transmitter and receiver. And your brain, it acts like a capacitor. It acts like the inner ear. It's an amplifier. And all these mechanisms can be channeled. Like, for example, like your mouth. Your mouth is also a Helmholtz resonator. If I move my tongue in a certain way, I can do pronunciations.
Yeah.
Right? If it's from the teeth or from my back of my throat, you can change the pitch to create a word that can be interpreted. Yeah. Now, is it possible, since our brains are electrochemically driven devices and organs, can we project as a transmitter a certain frequency out and have someone pick it up? Do we have the technology? I don't know. Is it possible? Yeah. Has anyone figured it out? Maybe. I don't know.
Well, like, don't they like they put those crazy helmets on people and then like picks up on their brain waves?
Yeah.
I mean, isn't that like proof that your brain is broadcasting a electromagnetic signal to some degree? Maybe how far it goes, that's a question, but at least they can pick it up by putting sensors on your head. So that's a thing.
Well, it's interesting if you even look at the construction of your brain, the way that the gray matter is even kind of snaky, right? It kind of looks like a sponge, right?
Folds or whatever, right?
Yeah, it has those folds over it. Yeah. And so those folds, just like a coil of wire, actually act as a capacitance. Every time you take a wire, which has inductance, and you turn one coil on another coil, you're creating a little bit of a capacitance between each one.
What does that mean, capacitance? What is that?
It's like two plates. Like if I have two plates that are right next to each other, like this, that is a capacitance, right? There's a dielectric between the two. It's very much like your cochlea of your ear, or even your eardrum. Actually,
sorry to ask this, but I'm honestly asking, what does that even mean, a dielectric? What does that mean?
Oh, a dielectric is like beer. Beer is a dielectric. The air is a dielectric. My saliva is a dielectric.
It's the material in between?
Yeah, it absorbs it absorbs magnetic fields, it absorbs electrostatic fields. It's just a material that absorbs some fundamental force lines.
Okay.
Like, exactly. It's just a medium that changes the way that it wobbles or interacts.
Huh.
And so when you have a capacitor, whatever you put in between the capacitor, like the arc reactor has a bunch of these little plates, you can actually cause the universe to fold in on itself or get trapped inside there with electron capture, which is what we do. And we're just using Mother Nature's fundamental mechanisms to induce nuclear fusion safely.
Does the arc reactor work in a vacuum?
Actually, it works better in a vacuum.
Why is that? I would have thought you needed something to fuse, right? I mean, am I asking, is this getting into crazy, like too deep? But I mean, if in a vacuum, what is there to fuse?
Wow. You're getting into a very philosophical discussion about if you have a true vacuum and you turn on the arc reactor, you can create things. Like you can actually create matter.
Is it pulling it from the other side of the veil or whatever?
We have not observed it in any of our studies, but what I can tell you is that when you turn the arc reactor on in a vacuum, everything starts working better. The voltage works better, the resonance works better, the amplification factor works better. So if we were to make a spacecraft that was operating with the arc reactor fusion on demand technology and take it into outer space, we may be able to do certain things that are only possible in your imagination.
In space?
In space.
Whoa.
Yeah.
I like where this is going. You know, I'm a big fan of pushing the limits, like flying cars. By the way, flying cars are kind of becoming a thing. So
that's true. You were showing me the what was it, the bike? It was like a bike that someone was on that would hover and fly over the trees.
Yeah.
It was invented by two guys.
Well, I think they used a jet. They used that was a jet propulsion thing.
It was battery powered though, right? It was like,
I don't recall that one. I thought there was a guy who made the backpack thing.
Oh yeah.
And then he was flying around with that, which is super cool. But then he put it onto a platform thing, and then he turned that into like a drivable bike kind of a thing.
That's so cool.
I mean, it's awesome. I can't wait for that stuff.
The future, what it'll be, where it's like, I want to go to the grocery store. Well, we're not going to drive on a road in one dimension. We're going to go fly up and go over and then down, and I'll be on my own little hover scooter. Like, how cool is that?
That's amazing. I mean, so many things are possible, I would imagine, with advanced technology, right? I mean, it's just, we just only are using a fraction of what's possible to us.
Well, I mean, we're still using gasoline vehicles, which is basically like, what is it, like 1800s almost, like 1830s, something like that.
Combustion engines.
Engine.
Fire. I mean, we're burning fire. We're making fire. We're still making fire and smashing things with rocks. Right?
Well, now we have nuclear fire with this technology. So, I mean, there are people that are there. By the way, I just want to thank you, all the audience too, for subscribing. We have like 285,000 subscribers now, and we just want to say thank you so much for coming along for this awesome journey of learning and education for nuclear fusion, first diffusion, and it's really exciting. And we're happy to, help teach you guys about the technology. Now, we're not telling you exactly how to do it because that's not something we should be doing, because it's just not responsible. But what we're doing is trying to teach you, like children, like Sesame Street, like this is possible. This is where we want to go with this. And the more people that get involved, the better, right?
Yeah. Well, and it's interesting stuff. I think when I ask you these questions, I'm genuinely asking you these questions. I really, and when we talk over lunch and stuff, it's like, there's so many things about science that open the possibilities of transforming the way that we live.
Oh my God.
And one topic that I keep hearing more and more about is plasma.
Mm-hmm.
So I'll tell you what I know about plasma, and then you kind of take it. Tell me from there.
I'm excited.
So there's different phases of matter.
Mm-hmm. Gas,
and
liquid, solid.
Well, I think of it liquid, liquid, gas, and then plasma, right?
Mm-hmm.
From solid to air to then plasma, which is
ether.
Ether beyond that? Oh yeah, maybe. Okay.
Yeah, think about it.
Ether. Huh. You know what's interesting is that like the Chinese element symbol, that we're getting way off topic here, but it has ether in it. It has the category, like a whole category. There's like earth, wind, fire, water, and then like ether, or there's many different names for it in different cultures, not just Chinese, but have these different names for it. But maybe like prehistoric people were like, well, that space thing is pretty vast. Maybe we should include that in the list. But regarding plasma, I keep hearing about plasma, cold plasma, hot plasma, plasma intelligence. What is it? What is it about plasma that we should be understanding that relates to the technology that you're developing?
Oh my gosh. So plasma in a academic sense is basically free electrons moving around in a dielectric.
Okay, but hold up.
Yeah, I know. I went real technical there.
I know the word dielectric. I'm like, what that one. But it's like I think it's like gas that has so much energy the electrons can't stay on the atom. Is that right?
It's like if you had a magnetosphere of the Earth, right? And then the sun is beating down all of its rays and all the charged particles, and because there's a magnetic field, the particles swirl to the poles, and then you get the aurora borealis, and then they swirl to the bottom, and you get the aurora borealis. But then those charged particles get dissipated and absorbed in the dielectric of the atmosphere. So it's a shield, it's a buffer. And then sometimes the particles will go around, and then they'll actually, there's another thing that they come around and they hit. That's really interesting, is that the particles will deflect into a focal zone, and then they hit, and there's this thing called a plasma echo, where all the charged particles hit each other in a single point, and there's a cavitation event where it pushes back, and there's extra energy that gets pushed back into the planet, but which might even have to do something with Schumann resonance, maybe, potentially. But plasma in the academic sense is just electrons ripped away from their atom structure, and they're just flowing. Electrons flowing.
But
continuously.
They want to come back. They want to come back to the atom, but there's too much energy, so they can't, right?
Correct. If you go in your room or into a kitchen, you turn on a light switch, you just activated plasma, because the conductive wire in your house is pushing electrons. It's flowing electrons. It's very small, but you're creating a small plasma field.
Okay, I have a very specific question for you. This total curiosity thing here. So my understanding is when electrons go from one energy shell to another and they bounce back and forth, they give off a particular frequency of energy, right?
Sound wave.
Is there a special kind of energy that gets kicked off when a electron that is in a plasma state comes back? Is there a special kind of an energy that gets dissipated?
It depends if the electron is in the cloud. If it's in the KLMN cloud, the orbitals. If there's an electron that's not even in any of those clouds.
Hold up. What's the KL? What are those?
Those are orbitals. So an atom has certain orbital shell levels,
right.
Much like
valence
a planet.
Shells?
Correct, valence shells. Thank you. And it's like an orbital planet circulation, but it's really not. And this is where Bohr and Einstein really kind of fought a lot. But the point is that if there's an electron in the K and it moves to the KL, and then it moves back to the K, it'll emit a certain frequency photon as a normalization. Okay.
Right.
I think what you're asking is if there is no electron in any of those,
yes,
it's a free electron.
Yes.
And it moves or gets deflected, will it emit a photon?
Well, if it comes back to the atom, if it comes back to
it gets caught up in it.
Yeah. Now it's orbiting the atom again because it lost a certain amount of energy, and it's back.
That's an interesting question. So when an electron, you're saying, I'm just getting it straight.
Yeah.
You've got an electron out here.
Yeah. In a plasma.
And it's plasmating.
Yeah.
Right.
And then it comes back.
And it gets jammed in here, and it's like, I'm in now.
Now it's orbiting again. Yeah.
So does it emit a photon when it does that?
What does it emit? Is there something special that it emits when it went from being a plasma to a orbiting electron?
I would say yes. Depending on where the electron would fall into. Sometimes it would just fall into the K. Sometimes it'll fall into the M. Sometimes it'll fall. It depends. It's all probabilistic.
Oh, it doesn't start on the outside and work in, or
it's a dynamic system. It could catch on the outside. It could catch on the inside. And there's another thing that happens too, Jason, is that if there's an electron that tries to get in, kind of like a sperm trying to get into an egg, right? When it gets in on the outer side, sometimes the inner electrons will go, oh my gosh, you've disrupted this stability. And then the inner electron will fall into the nucleus, just turning into a new atom. That's called transmutation.
Right, right.
And so when you have this plasma around atoms that are stable or trying to be stable, you will cause transmutation just at a low probability.
Okay.
That's positive plasma, like hot fusion. That's positive plasma.
Okay.
But in our situation, we create negative plasma intelligence, like Dana Kippel, where we suck in.
What does that even mean, plasma intelligence? I have seen that and heard that. But isn't, like, when you say intelligence, what you talking about, a physics effect? Or is it implying, like, if you were to say, like, all of the water in my bathtub goes down the drain, that's intelligence?
Mm-hmm.
Or is that just physics?
It's both.
Or is it implying that there's some kind of thinking going on?
It's both.
Huh.
It has to be both. Because, for example, if you're on one side of the hemisphere and you flush a toilet, it'll go one direction. If you're on the other side of the hemisphere of a planet and you flush a toilet, it'll go another direction. Yes, that's physics. That's based on gravity and forces and pressures and all that are localized. But there is an intelligence, a predetermined code of how it's going to go. And that's why it's hard to do simulations with AI, with general relativity, because they're missing pieces of the natural phenomenon of nature. And so you don't ever get, and this is why Terrence Howard is really making a lot of progress, is because with his, it's not keystone, but he calls it the linchpin.
Yeah.
His linchpin geometric shape.
That weird shaped diamond, that concave diamond.
Yeah.
Yeah.
You know what that is? That is the shadow of antimatter.
What the heck? What?
And he has literally made, and I hope he's watching, but what he has done with the linchpin design is that he's created the conjugate of a planet's gravity, which is the antimatter, but it's a shape, it's a shadow. So when you take the shadow shape of the linchpin and you plug it into an equation and you just keep adding more and more and more, in the equation, he can get a simulation of Saturn with the rings perfectly.
Wow.
Yeah, and that's the thing about, that's not mainstream science. That's a guy, an actor, who is an artist, who is really inspired.
And a scientist too, you know, I mean,
well,
legit.
Now he is, yes.
Yeah.
Because he's observing the universe and reporting on it.
I had somebody once say to me, like, we were talking about metaphysics stuff, and he said, you know, we don't understand how everything about gravity works.
Nope.
So how can we possibly draw boundaries around things we don't understand? That's the whole point of we don't understand them, right?
Mm-hmm.
There could be possibilities. You and I were talking about this related to like metaphysical stuff, about like reading minds and remote viewing and quantum entanglement.
Yes.
So quantum entanglement, if I understand this correctly, Einstein referred to it as spooky action at a distance.
Very good.
Yeah, I try to keep up with this stuff.
Leveled up.
I love watching this stuff. I just always end up, I've watched so many shows on like quantum physics, and after the end of them, I'm like, I don't know if I understood anything about that, but I know I can ask about it. That's what I enjoy about this, is the follow-up questions with you. I've seen what's that all about? But so quantum entanglement says that you can take two atoms or
Did you know that we're quantumly entangled right now?
No, how?
By gravity, by Earth's gravity. You have a mass, I have a mass. The Earth below us has a mass pulling us down.
Huh.
We're entangled in Earth's gravity.
Okay, but let me ask you like a finer aspect of that question. So here's my understanding of what I think quantum entanglement is, and you tell me if so I thought it was something that if two particles get entangled, then if you flip one, the other one will flip too. Mm-hmm. No matter the distance.
That would be an electron.
Okay, an electron.
That's like the most basic one.
And so the spin of one immediately affects the spin of the other. Across any distance of space. Mm-hmm. Which would mean that somehow that's happening faster than the speed of light.
It is.
But okay, this is $1 million question. Like, I got to ask you, what's entangling them? How is it that they're related to each other is there a field connecting them? How is that possible?
The only way that you could have an instantaneous entangled particle that would go faster, the information would go faster than the speed of light, would be when there's actually two. One, you would have negative light.
What's that?
Exactly. There's that. And then another one is where you have a situation where the permeativity of free space, which is the resistance, is 0. Right now, the permeativity of free space, the resistance is 377 ohms, which is a resistance. It's the resistance of everything. It gives the speed of light its speed limit.
Oh,
okay. It's a resistance in a circuit. By the way, the universe is a gigantic circuit. And so there's two ways to have the entangled particle communicate instantaneously. One, negative light. Two, 0 permeativity of free space, 0 resistance. And if you have 0 resistance, you're instantaneously there. Just like a spacecraft, actually, warp cores.
Or maybe I'm just totally throwing this out. Are they maybe they're the same thing across space, and that space doesn't matter if...
Yep. That's pretty good.
Like
that's actually where space basically goes to null.
Is that a wormhole?
Yeah.
They're connected by a wormhole? Some tiny...
Everything in this room has the ability to open up a wormhole because everything's full of electrons in this room. And remember, 99.99% of the beer bottle is empty space.
Like this one right here.
Yes. And it's... Okay, now here's the thing. My beer is 1/4 empty. Your beer bottle is empty. Now, that's a frequency. Yours is much lower. If I were to create a situation where my craft had the harmonic oscillator built inside of it, and then the waves on the outside were out of phase from what was going on in the inside, basically a light box, that was continuing the amplify to like gigawatt power.
It like pulls it through space.
It'll pull it. It's an out of phase conjugate force that will, you don't have like an explosion propulsion like a rocket, like whatever. You have a out of phase trajectory pulling of light. The secret is negative light.
What does that mean though? Negative light? Okay, so I think myself, like a lot of people out there watching this, thinking, okay, I understand light is a photon or of energy that gets emitted from something that's vibrating, and then that thing flies through whatever, and then we receive it or it bounces off stuff.
Ooh. You're making a classical assumption that light is traveling. Okay. I'm going to back up. There's actually two lights. There's a one-way light and there's a two-way light. Now, you can watch videos on YouTube about this, and they have really good explanations. Veritasium does a great job, and Sabine Hasselhoff does a great job. They all do great jobs. But what you need to understand is that a one-way... We have never in history detected the true speed of light. Ever.
Isn't that what E equals mc squared? Isn't c squared the constant of light squared? Is that what that is?
But here's the thing. You're right.
Okay.
That's true. And that just means that when you have light you have a mass turn into light, it goes in all directions.
Wait, is this why you say plus or minus?
Yes.
Okay, go ahead.
Yes, that's exactly right.
But what's the minus? How is minus light speed?
Yes. And here's the thing that the scientific community has missed ever since James Clerk Maxwell back in the 1880s, is that in order for him to determine the speed of light, he took the permeability and the permeativity of free space, which is the electrostatic field and the magnetic field, and how they interact with space. He took those two numbers, multiplied them together, and he had a square root on it, over 1. Do you know that if you square root a number, you get positive and negative? So C squared is also negative and positive because he square rooted the permeativity and permeability of those values of this.
So therefore you can use a negative number too because you're squaring it.
You have to. It exists because of the math.
Huh.
You can't. If you square root 9, you get 3 and negative 3. If you square root 2 or 4, you get negative 2 and positive 4. It's just a constant.
Right.
You can't just erase one of them and say it doesn't exist. It's there. And this is why it's so hard to determine the real value of the speed of light, is because when you start the stopwatch and the light's going towards you, when do you know to turn on your stopwatch to let it know when it hit you? It's a signal.
Couldn't they like shoot a laser through a vacuum or something like that?
Oh, they do that all the time. And that's why LIGO is having such a hard time really picking up these gravity waves, is because potentially gravity is not even a positive wave of light. It's a negative wave of light.
Huh.
Yeah. Maybe it's just
negative wave of light.
Yes.
At a super low frequency or super high frequency?
Well,
super low, right? Super low.
I'd say both.
But I thought LIGO was that L-shaped thing. We talked about this in the other one. Mm-hmm. Is that L-shaped thing in Eastern Washington? That's the only reason why I really know about that. Is that that thing detects? There's like mirrors and lasers, and then if
interferometer shift of
right
the diffraction period.
Right. If there's a wiggle in it, that means the whole thing vibrated at some micro amount, and that means there was a gravity wave that came in, right?
Right, but remember the gravity wave of Earth, which actually is a little bit of negative light. Remember, we need to back up and understand what time is, right? We need to talk about time for a second, time dilation, right? Because if I'm out here as an astronaut, and this is Earth, right? And I'm way out here, time is going really fast. Like I'm aging way quick right now. And we have studies on this from NASA, and they had twins and stuff like that. I forget their names, but if you take this astronaut and you bring them closer to Earth, let's just say you put them on the Earth's surface, they'll age slower. This is called time dilation.
Right.
Okay. So the question is, if Earth's gravity is causing the slowing down of time, can you not stop time? Can you freeze time potentially? If let's say instead of Earth's mass, you had a black hole's mass, which is humongous, is it possible that you can freeze time? And if you freeze time, is that not the definition of taking the ohms of 377 ohms and making it 0, and then you've frozen time and space? And now you've entered into the realm of whatever.
Is that, and so
plasma intelligence.
Why is that plasma intelligence? So that's the thing about it, that in word intelligence is the one that it gets me. It's like, why is that intelligence? Or is that like the Dana Kippel stuff? When you call it intelligence, like what I think about when I think of intelligence is like a monkey can figure out how to stack those. You ever seen the monkeys do the thing with the blocks and the circles, and they stack them in the things, and they get a peanut, and they're doing it super fast.
And the screen, they do like the figuring things out on the screen.
That's another thing. Yeah. Okay. So here's an interesting, this is a side thing.
No, it's
where the depths of, by the way, I want to get back to what negative
light is, because
that's fascinating.
That is gravity, by the way.
Negative light is gravity.
Yes. Because positive light is like, for example, the sun, it's emitting energy. Okay. And actually those charged particles and that light energy that's positive and pushing out, that dense energy, it actually pushes and holds things back. Right? It pushes them back. Right?
Isn't it the sun a constant tug of war between the energy emitted that's blasting everything outward, and then the gravity that's pulling everything inward?
Yes, exactly. It's all a harmonic oscillator using particle oscillations as an energy generator, right? And let's just put it this way. If we take your guitar and you grab a key and you string it, right? Yeah, go ahead. I'll explain this real quick while he's grabbing it, because he's going to knock stuff over. I know he is. Yeah, there he goes.
Yeah, I almost did.
So if you take your string and you roll your hand down it, but you're plucking the string, periodically you'll get more of a negative wave action. Okay, so go ahead and roll down the electromagnetic spectrum real quick.
Okay.
We're going to X-rays. Keep going. We're going to gamma rays. And they're just getting higher and higher energy. Yeah. They're tighter and tighter and tighter. and now you just got cancer.
Oh, wait, let me go back. Let's go back.
Okay, now you got ionized. Your electrons.
I just want to suntan at the beach. That's all.
Okay,
That's
so
all I'm asking
keep
for.
going down. Now you're in microwave. Now you're in infrared. Now you're in visible light. Now you're in radio. Now you're into sounds. And they're all hertz. It's just the same mechanism, just in a different vector, which would be compressional or longitudinal, but it's all relativistically the same. Like your brain takes electrical signals and converts the wave energy from light waves into your eyes, or the sound waves into your ears, or the touch, the heat. I can feel that. You're just basically interpreting electromagnetic radiation and turning it into electron flow. Wait. You can do that? You can turn waves or suck in electrons to turn it into light? You can do that? Your brain, nature, Mother Earth, and plasma intelligence, it has it all figured out. And it's our job as human beings to figure this out. Because if we don't, we're in big trouble.
Yeah. I mean, the thing I love about technology and invention is it's that only like inventions can make things 10 times or 100 times better. Like as messed up as things are, we can always just make stuff better, by creating better inventions that suddenly, like recyclable plastic, you know what I mean? Like all of a sudden, or some worm or some bug that wants to eat plastic. So here you go, like there's always a solution to every stupid problem we make.
Totally.
One thing, while I got the guitar out, I just want to ask you about something. You talk about energy generation.
Particle oscillation as an energy generator.
Particle oscillation through energy generator. It sounds like a tongue twister. Try to say that 3 times fast. Wait,
say that to your girlfriend.
Particle oscillation through. It's a tough. Yeah, that's really some sweet talking stuff. The physics don't seem to work as well. But you mentioned like different frequencies. Do you like on a guitar you can play a chord? Like here's a major chord. That's
gravity.
Do you use different frequencies?
That's gravity, dude.
Really? Huh?
Yeah, because if you have one key, and then you have another key, and then another key, and then you strum it.
Yeah.
You're actually doing competitive addition, subtractive,
right?
And you're creating a well. And here's what I would say too about Earth. Earth is in a very special orbit around the sun, and the moon around the Earth creates a very special wave of energy that creates the potential wave energy of plant life, animal life, sponges from the ocean, thermal vents, and the chemistry starts interacting with the wave gravity, and the wave gravity interacts with the chemistry, and then you start having carbon fusion, carbon, nitrogen, oxygen, and then you get sugars, and then you get, potassium, and then you get, ATP pumps, and all of a sudden there's the prerequisites for a organic creature to show up and be able to go through some type of spiritual, maybe even resonance,
right? To
lock it in, to then, okay, well, today I'm a creature that just worries about making an anthill in this lifetime, and then the next time I get caught in that gravity wave, I'm like, oh, I'm drinking a beer trying to tell people about nuclear fusion. Like, okay, what's the next lifetime? Like, what's the next tier? Like, everyone goes to work to make money. Why? So I can have more money. Why do you want more money? So I can buy things. Why do you want to buy things? So I can experience more.
Yeah, we were talking about that at lunch. Also survival, legit. Like there's a lot of people, you and I were talking a little bit about the positive sort of outcome of this. And that's why, I was, you and I have talked about it a couple of times, putting together a segment talking about the future of technology, or how this technology can be used in the future to make the world a better place.
And it will.
And how when you think of this, what are the top use cases for it? If you can speak to that.
Yeah, there's, in my mind's eye, my mind's eye says, hey, we have technology where we're running every single internal combustion engine on.
Can I pick up one of these?
Oh yeah, yeah.
I love this.
I think
the spark plugs. I love
this one's good. I think the other ones are locked.
Is it okay to call it a spark plug, or is that just totally under?
No, it's a quantum injected spark plug. Like the first technology
cool.
I see is like we're running on clean water energy, for airplanes, cars, and whatever. And then the next technology is we're creating basically new batteries that last 100 times longer. We're talking about technology that would just blow your mind. And when you have nuclear fusion figured out, which we do here at Quantum Kinetics, and we're legalized it and we're trying to push it onto you guys, and so that it's coming, guys. Like this technology it's here and it is coming. Now, who's going to help push it across the finish line and get it into your life? We don't know yet. And that's the history, that's the timeline of the plasma intelligence that we don't know yet. And that's a neuron that hasn't fired yet. We're trying to get the node, the axiom node, to get ready to get enough potential to fire to have it be a reality. And I'm so excited to be even talking with you about this. Like I say this every time, but it's just like, dang, it's so cool. And
I think a lot of people just assume that they're like, this is what I think about the way people, okay, there's two sort of obstacles that perhaps are part of what you're trying to do that needs to be overcome. One is that when you talk to people about cold nuclear fusion, bro, it's already been tried.
Oh, it's done, baby.
That's the
it's
goose
done.
is cooked.
It's done.
No, that's done.
It's done, bro.
That's it.
Like there's no going back now. Like we're getting ready for a documentary and it's going to be launching in December.
Yeah.
And you've seen a little bit of it.
I love it.
And thank you so much for being the art director on that. Because you're going in the credits
thank you.
At the end for sure.
It's so easy to look at somebody else's creation and nitpick it when you're doing the heavy lifting of putting the scenes together and watching scrubbing video over and over again. But when you just like sit back and, cherry pick little things, like put that a beat forward or back, it's easy, but it looks awesome. I really watched it. I wanted to I would have watched it again. I mean, and you're not even done.
What are we? I think we're 22 minutes into it, and we're trying to make it to be about a 40-minute documentary.
Yeah.
But I'm so happy to have this come out, and from this point forward, ladies and gentlemen, nuclear cold fusion is here. There's no going back. Nobody can undo this. And this is a snowball that has begun rolling down the mountain, and it cannot be stopped. I'm sorry to say.
That's the thing too. That's such a declarative thing to say, right? Because the stigma with nuclear fusion is that it's 30 years away,
20, 30 years away, always,
and it always will be.
Yeah.
And why is that? Is that because the people in hot fusion have been shooting lasers at their plasma balls?
Are they giving themselves blue plasma balls?
They're also squeezing their plasma balls with magnetic confinement. So that's gotta hurt a little.
I mean, you don't want to put your plasma ball in a vice, do you?
Those guys need some help. I mean, is there anything we can do? No, but all joking aside, I mean, so let's take those two objections, right? Like one objection is, and I've asked you about this before, but I think it's such an interesting thing because the cold nuclear fusion has been tried. Those guys messed it up and were falsifying their information or didn't know what they were talking about. And that's it. But the rationale is that there are other things that could be done, and you're doing other things. Is that? Yeah. How do you see that distinction?
Just to essentially, Fleischmann and Pons, they were technically doing fusion. They were doing electrolysis, and they had, the electrodes, the palladium electrodes were doped with hydrogen, and they basically turned into a hydride, and they were doing electrolysis, and they were having fusion sputtering events. It was low probability. It was happening. It was anomalous, but it was happening at very low percentages. And then when they detected something and they're like, oh my God, it's doing it. But then when someone else would try to replicate it, it wouldn't do quite what they had said or saw or witnessed. So technically they were doing fusion. Like every time you put an electrode and another electrode in seawater and turn on with DC current. Technically, you're doing fusion. It's just super low yield.
Okay.
Because the current going across the dielectric of the seawater and the electrons bouncing into the ions and all that, periodically there will be carbon showing up for no reason. Periodically, yes, there will be. Is it a high probability? No. Is it statistically significant? No, it's not. So everyone just glosses over it like an anomaly. But when you have a new type of electricity, the quantum kinetic well technology, every time you turn the knob, bam, nuclear fusion occurs 100% of the time. It's consistent, it's reliable, it's safe, and it doesn't use bulk ion heating. It's not necessary. You don't, like, for example, does a nuclear star form a core first before it ignites? Like, the question is, like, what are the 4 stages of how a star even ignites?
I don't know.
Nobody knows. Nobody really knows. Okay.
Huh.
Actually, in 1920, the theory of the stars was that they were a giant black ball of carbon coal that was burning in space. That was the original theory, which is half right. And then in 1935, someone came along and said, actually, it's a plasma ball. The plasma flame is on the outside, blah, blah, blah. Technically, that's 50% right, too. But to differentiate and pull them apart and say, no, that one's right, that one's wrong. Dude, you just ruined the whole thing. Technically, they're both right.
As always, many times is the case. But by the way, with those guys, do you give them props? Are they the shoulders of giants that you too, in a way, have added to what you've done? And thanks to those guys, I believe in honoring, because as an inventor, like, we do so much stuff that doesn't turn into anything, but in a way, defining what didn't work helps the next guy, because that guy's like, wait a minute, he tried this and that, or she tried this and that. And now I know that at least I can see what they did, and now I can try something else or build on that. Do you give those guys props and credit?
I try to give as much as we can, right? Like, especially James Clerk Maxwell, Michael Faraday, Heishman Hertz, Niels Bohr, Heisenberg. These people were really pushing the envelope and pushing back on the establishment of a conventional thinking.
Yeah.
And even there's an individual by the name of William James Sidis. He got ridiculed. He had an IQ of well over 250 or 260. He was the highest IQ ever recorded, and he wrote a book. It was called The Animate and the Inanimate, basically the living and the dead. What made them different? What made them, like, how do you cross that line between the two? What was the mechanism? And he, in 1920, wrote this book, and it got published in 1925, and he published it, and everyone laughed at him. Everyone thought he was crazy. He defined a black hole before even anyone else. He talked about negative light. He talked about negative energy. He talked about balls bouncing up a staircase because they're going back in time, like pulling energy to go back in time. Like, he was so smart. And you know what the academic community did to him?
Ridiculed him and called him a kook.
And you know what he did? He ended up committing suicide. He was so traumatized by the academic establishment making fun of him, when he knew in his gut he was right. But he didn't have the science, he didn't have technology, he didn't have amazing telescopes. Like, for example, James Webb Telescope just proved this week that 13.75 billion years ago, there was probably no Big Bang. Can you imagine?
That's so wild.
Gosh.
The things that, what I find fascinating, like how we think we understand the world, but then something comes up and it then redefines the very premise of everything we thought. Like the Hubble telescope. There was a time when we could see the stars and we thought we were in a galaxy. And then he saw, I believe they saw Andromeda, right? And they're like, wait a minute, if that's another galaxy, then all that other stuff way out there too is maybe other galaxies. So take the context of where we are and multiply it by a million, bazillion, quadrillion, infinity, whatever. The universe is infinitely huge.
And expanding.
And that changed everything. Yeah.
Yeah. And the thing is the moment you're a scientist and you start saying that's impossible, you literally have done the ultimate sin of being a scientist. your job as a scientist is to look at the data, observe the data, and make conclusions of the data you see, not discriminate and not throw it in the trash can just to please your own political or your social, economic, or whatever platform you're trying to appease.
I think it's because our ego kicks in and we're like, it feels good to be a big shot who can explain how things work. Right? You're just like, well, that's not how it works. We're the center of the universe around the earth. You know what I mean? Like at some point,
well, that's heresy. I'll burn you at the stake.
Yeah, at some point that was the way to go. Is like, well, we're just the center of the universe. How dare you? But the reality is as we go through more exploration and invention, we find out that the parameters are wide open. Mm-hmm. And I'm sure what you've done, you meant in the documentary. I don't know if I can speak to it, but. Yeah. You mentioned a moment where you felt like you kind of got a message that there was a different way to do the thing you were trying to figure out.
Right.
And so I imagine you must have been running up into a dead end about this thing you were trying and you couldn't take it any further. And then you had the audacity to try something in a different way. Mm-hmm. And lo and behold, that was the thing that solved it. But it was contrary, or
it was totally backwards from normal electronics that I'd learned throughout, like textbooks and reading college textbooks and everything. And I was just doing, as an artist, I was just doing what was written on the pages and trying to do new approaches, and it just was not working. And so, I mean, I don't want to go too far into it because the documentary is coming on December, but basically, if you've read the book, essentially there was a whisper that said, you're basically there, just do it like this. And I thought to myself, well, that's silly. No one would ever do it that way. It's non-conventional. I don't even think it would work. It would probably dead short and blow up. And I just said, I'm at the end of my rope. I might as well try the dang thing. And lo and behold, I turned it on and it worked. And I'm going to tell you, I'm sure that there have been many other people 100 years ago that felt the same way about alchemy or, the telegraph, or, the guy who invented the key on the telegraph was an artist.
Oh, right. Yeah.
Morse. Samuel Morse.
Oh, really?
He was an artist.
Of Morse code.
Yeah. Huh. And so how come historically it's always been these weird outlier guys like the TV tube? Philo Farnsworth was a Utah farm boy who was doing line scan because where he got the inspiration for the line scanning of the TV was from farming.
From mowing the cornfields?
Yes, he was going back and forth.
Harvesting them?
Yeah, huh. And he was like, I can make electrons do that on a fluorescent screen.
Huh.
But I can do it 60 times a second.
Oh, right. Is that scan line?
Yes.
Is that what that is?
CRTV scan line.
Oh, huh.
That's all gone now because that technology is basically ancient. But
now but again, a step towards.
Well, that's what this is. The arc reactor. If I don't mark this over, the arc reactor is basically a vacuum tube that is very similar in design to Philo Farnsworth's scan line.
Huh.
It has magnetic fields that deflect the electrons, but we deflect them in a spiral pattern, like a galaxy. Fibonacci, just like the ear. Going all the way back to the beginning of this conversation.
Yeah.
The ear. The ear is Mother Nature's process for amplifying wave hertz pressure to make it turn into electrical signal for your brain to understand.
Right. Isn't that interesting that just like the guitar pickup, we were talking about that, the guitar, when you play the strings, and by the way, there's an interesting thing. I recently found out you can plug a thing onto the guitar, a wireless thing. So the guitar is not even plugged into that cord.
It's Wi-Fi?
It's wireless.
Okay.
And that thing, so the guitar doesn't need power to do that. What it's doing is it's sending the signal through this Bluetooth thing to the amplifier. So you plug the Bluetooth receiver onto the amplifier, and the guitar itself has a wireless thing. You can walk around and play with it without being connected to a cord.
What if that's the beginning precursor to mind reading?
Huh. Well, this is what we were talking, I wanted to get at earlier, which is, so you and I had a phone conversation.
I need another beer.
Yeah. I actually got one, and I had another one out. What happened to the other one?
mine over there.
Oh, you already finished
grab
it?
later.
I already do.
Yeah,
Already a couple down.
we probably should think about wrapping up.
Yeah, I know. Not drinking beer into infinity.
But I wanted to say I really enjoyed this conversation, Jason, because it is really touched on a lot of things: negative light, the amplification of electromagnetic radiation to your ear, to your brain, which is a signal, which is based.
Yeah.
I want to say that a black hole is very similar to your brain. It's a data processor that holds on to information.
Wow.
Yeah.
Not just a giant gravity thing?
Well, I mean, it's information light.
Huh.
And does it convert light into mass?
And is there anything, any place I could go to learn more about things like black holes, mathematics, physics?
Go ahead and check
like
out www.quantumkinetics.co. Yeah, there's tons of places. I mean, actually, YouTube's kind of a wonderful place.
What about Brilliant? Aren't they a sponsor?
Brilliant. They were a sponsor, and not for this video, but we really enjoyed work with them.
That's cool.
Fantastic.
That's awesome. Well, there's so much to learn about, and I mean, I think what people love about the videos that you and I do, in particular, because I just like pelt you with questions about random stuff. There's so much to learn about, and one thing I always enjoy talking with you about is that, like, I'll come to you with a thing, and you're like, "That's not how it really works." I'm like, "What are you talking about?" And then it's like a whole new explanation of it, which I think is really cool.
Well, it's like your music. I ask you very specific questions, like, okay, you have a chord, you have a what was the word? You have
a scale.
You have a scale. And how do you, like, if you were playing earlier for me the sound of like the Star Wars.
Yeah.
You know, and it was like, hey, how did you jump from the 12-12 to the next 12 and do it so smoothly? There is a mechanism that you have to learn in order to make that jump, almost as if you're doing a jump to another universe in a way, between free space. I see the chords. I'm really going into something really interesting. That the chords, like the 1 through 12, would be like the Milky Way galaxy. Those are my chords. But I could go to another universe by jumping free space to the next 112.
Yeah.
But I can only jump it if I follow the Fibonacci sacred geometry spiraling to phase shift into that new world properly. And if you look at a sunflower is really interesting because it's all mathematics just in the sunflower, which is also this
Fibonacci series again.
Yep.
It's in everything.
It's in your eyes. It's in your ears. It's in the whale's tail. It's in ants' bodies.
Your finger digits, your arms, your facial thing, proportions. Yeah.
And just to close up here, because we're at, over an hour, that the universe has all the answers. And if you're paying attention and an artist and open to learning and keeping the brainwave open, Jason, we can tap into technologies that are just beyond comprehension and will blow away most physicists of today.
I'm so excited about it. I love the idea that we can redefine the future, make it something better.
And it's really an honor to be on this journey with you and everyone else and all our investors. Thank you so much for coming on for this great journey. And we're not, I'd say that we're coming into the next chapter of the book, which is going to be the most exciting part. And I'm really looking forward to launching the documentary, and I'm really excited to work with you on the art direction of it. So with that being said, Jason, I mean, this has been a really fun episode.
Yeah.
So thanks.
I like it. We got to drink beer on this one too. It's great.
No sponsor though, but that's okay.
That's okay.
But so we'll go ahead and close up. And is there anything else you want to say before we close?
Always a pleasure.
It is a pleasure. It really is. There's something about being in front of the microphone and teaching the world that there's something magical about it.
There's so much to talk about too. I'm looking forward to the next one.
It's endless.
Yeah.
All right, guys. So thanks for tuning in to Quantum Kinetics, and we will see you on the next one. Take care.
Bye.